couple years ago, I spoke at an event in New York City talking about climate change. And it was kind of surreal because when I grew up in an agriculture town, population 500 people, and everybody was farmers. So I go to this event in New York City, and there's all these little old rich ladies who put on this event, and they're looking at me kind of bug-eyed, and they go, "You're the first farmer we've ever met." Now, I felt like I was on display with my scientific name, on the plate in front of the glass, So, and they said, "We thought farmers didn't believe in climate change." And that was their polite way of saying, "We thought farmers were too stupid to believe in climate change." Because that is the general presumption, right? I mean, your IQ is directly proportional to the population of the city in which you live. I haven't found that to be true in my travels, by the way. So let's talk about climate change. And a few years ago, when I was talking about different topics, organizers would say, "Don't you dare bring up climate change. You'll make all these farmers mad." So I spoke about climate change. So they ask me, why are farmers so skeptical about climate change? I say, well, number one, we make our living by the weather. We watch the weather forecast. How many of you have noticed that every day there's a good chance of rain 10 days away? And then the next day, it's still 10 days away. Day 3, still 10 days away. It never gets any closer for some reason. And says here, 10-day or longer forecast is only right about half the time. And here these bunch of pinheads are sitting there with their computer models and telling us what's going to happen in 50 years. They can't even tell us what's going to happen next week. Forgive our skepticism. Some of us are old enough to remember that in 1975, all these same scientists were telling us the world's going to come to an end because we're entering another ice age. Anybody old enough to remember that? Yeah. Said, okay, were we supposed to believe you then, or are we supposed to believe you now? And because the average age of a U.S. farmer is about 70, most of us remember those days. Most of the people sitting there, just stop oil protesters, are about a third or less of that age. Don't remember those days. Another thing is we're very skeptical of bought and paid for science, because we've been on the receiving end of bought and paid for science all the time. Maybe more than any other industry. And the way you get rich is to invent a crisis and then put yourself in the position as having a product, or personally being the solution to that crisis. The only better scheme you can get is have the government pay to create the crisis and then use government-funded money to pay for your solution to the crisis. Now, I can't think of any recent examples anywhere along those lines. And farmers are very suspicious of abuse of power. Like, most of us see the proposed solutions to climate change as, hey, You guys give me your money and I'll fix your problem. And give me ultimate power. And we see that happening all over the globe. Give us your money and we will fix your problems. You will own nothing and you will be happy. Great. Can't wait. Give you all our money and we'll own and give you all the power. And somehow our life will be better off. So, but let's talk about climate change. So, I've put together this climate decision-making chart, and there's really two possible realities. One, either climate change is a myth, or climate change is real. It's one or the other, right? And then there's two possible courses of action. One is to do nothing, others do something. Okay, so I made this chart here. So let's talk about the first one. Let's just say climate change is a myth and we do nothing. Okay, what happens if we do nothing and climate change doesn't happen? Well, the only possible upside here is that we get to make fun of all the silly climate alarmists. Okay, but yay. Doesn't put a dollar in our pocket, doesn't help anything. But we got to do nothing. But what if though, we do nothing and climate change is real? And what happens if climate change is real and we do nothing? Well, we descend in this post-apocalyptic world. We can be, like Mad Max, and everybody's fighting over limited food and water. So, what do the scientists say? Well, if you go to the UN thing, this is what they said is going to happen to rainfall. Looks kind of ugly. And that's starting in 5 years. Here's what they say is going to happen to temperature under two different prediction models. Personally, I don't swallow everything scientists tell me, because if scientists were right 100% of the time, they would all agree on everything, and they never do. I mean, I travel with scientists, and they get into bar brawls over disagreements over which theory is correct and which one isn't. So scientists are never in unanimous agreement. So I like to go to what works better, and that's the power of observation. What's happening. So here's what I've observed. When I was a kid growing up in Kansas, this is what possums looked like. Now, living in the same place, this is what possums look like. They've grown shells. Crazy. So, sorry. How come I'm not, so this shows the movement of armadillos. The northward range of armadillos is limited by frost depth, because when they make their burrows, where they spend the winter, they have to dig below the frost line. And their ability to dig below the frost line, that frost line isn't as deep as what it used to be. And this is how it's been changing. So, armadillos lived in Texas for thousands of years, but in the last 70, look how far they've moved north. And that red X, the dark one is the 50s, the gray one is the darker gray is the 70s, the next one's the 90s, and that red X is where there are armadillos now. And they are in Nebraska. So they've moved from Texas to Nebraska in 70 years. So when I talk to people, they say, well, I don't believe in climate change, but this weather sure is getting funny. I think we all kind of have that observation. Weather is getting kind of funny. So what if climate change is real and we do something? Well, I'm going to explain how nobody has more power to alter the climate than the people in this room. I'll explain that a little farther. And when you can fix an issue, like I said, create a crisis and then make yourself the solution to that crisis. Hey, works for Fauci. Why can't it work for you? Okay, so why do you buy insurance? Well, in case the unthinkable happens. So what if climate change is a myth and we do something? What are we out? Well, that depends. That depends on what we do. What if the things we did created a world free of famine, floods, and droughts? That'd be a good deal. What if it made you guys more money? What if it made cleaner water? What if it made cleaner air? What if it made healthier food and more wildlife? Wouldn't these all be good things? So we're skeptical of climate change, heavy-handed legislation coming down from the government, or worse, a world government that's really nothing more than an attempt to gain money, to concentrate wealth and political power without really fixing any solutions. If you fix the solution, you lose your power. So there's two ways to reduce CO2 in the atmosphere. One's to stop emissions. What happens when we restrict fossil fuel? People suffer. Because like Jimmy Hoffa said, if it got to you on a truck. And when the cost of transportation goes up, the price of everything goes up. Who suffers most with rising prices? Poor people. The most economically marginal people now. If we focus climate change solutions on restricting fossil fuels, then poor people will suffer. What if instead, though, we took a different approach? What if we took carbon out of the air and we put it into soil? Can you tell which of these handfuls of soil has more carbon in it? Which of these handfuls of soil would you rather grow in? If it's not obvious, you can ask some of the folks in here around you. These are actually the exact same soil taken from opposite sides of the road. They've just been farmed differently for the last 50 years. So, U.S. drought monitor. That's kind of ugly. That's from a couple years ago. I don't think it's changed a whole heck of a lot since. It's a sad thing. That seems to be kind of a static state now, doesn't it? When are we going to stop calling it drought and just call it the new normal? And when people ask me to describe where I live, I said, well, I live in a desert where it floods quite a bit. Does that seem to be becoming more frequent? Our rainfall becomes less frequent, but it's more severe when it happens. We're having less rain, but more floods. Does it seem a little something up there? Is that a red flag? So the solution to all of this lies under our feet. Not if you're walking on concrete, by the way. But if you're a farmer and you're walking on soil, that's the solution to all of this. Creating more of this. Okay, so, well, how much good can this possibly do? Well, let's do some math. Well, the current CO2 in the atmosphere, it's gone up about 50% in the last 200 years. That we know, that we can measure. When you do the math, that's 875 and a lot of zeros tons. 875 billion tons. And about a third of that have been added in the last 200 years. 240 billion tons. Remember these numbers. There'll be a quiz later. How did it get there? Well, a lot of it did come from fossil fuels. But only about 5 years ago did the amount from fossil fuels that went into the atmosphere exceed the amount that came from soil tillage on the North American continent. When soil is tilled, the organic matter that's in the soil, remember good soil, bad soil, what was the difference between those two handfuls of soil? Organic matter. That's carbon. When you till that soil, this is moldboard plow, disc harrow, chisel plow, no-till. This is the amount of organic matter lost over the course of a year. The more severe you till, the more organic matter goes in the air. This is enough to be compensated for by the return of crop residue. This is not. This is where the CO2 in our atmosphere is coming from. About half of it. Actually, and if you look over throughout history, since the dawn of farming thousands of years ago, been a lot more CO2 in the atmosphere that came from farming than from fossil fuels. Fossil fuels are catching up fast because we're burning a lot of it. But farming had quite a head start. So what can we do about it? Well, if you look worldwide, 4 billion acres of cropland, 16 billion acres pasture and rangeland, about 20 billion acres overall. Let's do the math. If you increase soil organic matter 1 percentage point, now that's a percentage point, not a 1% increase. So that's like going from 2% to 3%. Let me clarify that. That's 10 tons of soil organic matter. And a ton of organic matter will take 18 tons of CO2 out of the atmosphere. So we take that 20 billion acres of agricultural land, 18 tons for every 1% increase in soil organic matter, that takes 360 billion tons of CO2 out of the atmosphere. How much has been added in the last 200 years? 240. That's 50% more. How many of you want more organic matter in your soil? Some of you guys are a little slow to catch on. Every hand should have went up right then. This is a good thing. This is a good thing for your pocketbook. It's a good thing for the planet. We want carbon out of the air and in the soil. So, how does CO2 get out of the air and into the soil? This little process called photosynthesis. CO2 plus water makes sugar. Good chunk of that sugar leaks out. This is a root tip. And that sugar is leaking out of that root tip and feeding microbes and making soil organic matter. Carbon. How do we add more of that? Well, one thing is, you see this is a cornfield, and this is a cover crop that's growing when that would otherwise be bare. It's incredibly discouraging to me to fly over the Corn Belt, fly into Chicago, or Minneapolis, or Cincinnati, and look down out of the window this time of year and see nothing but brown. What color is photosynthesis? Green. When you don't see green, that's a problem. It's a problem for you, it's a problem for the planet. The other thing that all that residue does, not only does it put carbon in the ground, what else does this help with? Anybody worried about water? You cover that soil and it goes in the ground. And what else does it not do once it's there? It doesn't evaporate. This is infiltration increasing. This is evaporation decreaser. We should want more of this. If your management doesn't provide this, your management probably ought to change. Another thing that does, that is just cover crop. Everybody says, oh, we got to go back to tillage because we can't control this herbicide-resistant Palmer amaranth. We can't control this herbicide-resistant. What do you notice? You see the line right here between the part of the field where the guy would try to cover crop on half, didn't on the other half? What do you not see over here where the cover crop was? Weeds. Yeah, we can manage this stuff for weed suppression. Otherwise, we can continue to buy glyphosate manufactured in China. This guy's actually a friend of mine. So, and he's dining with Xi. We can continue shipping money to China every year for our weed control solutions, or we can figure out how to make weeds create conditions in the field where weeds don't thrive. Oh, and we can add income streams from all this stuff. Here's that rye in the spring. Turn all these little calves out there. They're just happy as clams. I honestly don't know how happy clams are. Seems like a miserable life to me, but I've heard that expression, so I used it. So, here's a cover crop put in after wheat. So when all the pastures are drying up, losing nutrition, late summer, look at this. Steers will gain over 3 pounds a day on this. I had a client tell me that his gained 4 on a mix just like this. What about fertilizer? Anybody have this feeling? Like 2 years ago, this is brutal, right? Whew. What's the number one fertilizer that you spend more money on than any other? It's nitrogen, right? Yeah. You know where a good chunk of our nitrogen comes from? About 15% of the nitrogen fertilizer that Americans put on their fields comes from Russia. So we all know that nitrogen makes the grass grow. This is 0, 50, 100, 200. Nitrogen makes grass grow. You got to have nitrogen. And the only possible way to get nitrogen is to buy it from Big N, right? You got to go beg your banker for more money so you can ship that money. Hits your hand, and about a millisecond later, you write a check, goes to Koch brothers, who live down the road from me in a mansion bigger than my farm. I think they're doing okay. But that nitrogen can cause issues. It can end up in groundwater, and when it's sitting on your field and it can denitrify. And one of those nitrous oxides is equivalent to 300 CO2s as far as global warming impact. I'd like to spend less money on fertilizer. Most people would like to have less greenhouse gas equivalent. When that stuff ends up in water, this little town of Bogue, Kansas, it had 136 residents. till they found out the drinking water had well exceeded the toxic level of nitrate. They put in a $2.6 million water treatment plant to take nitrate out of the city drinking water, which essentially is slapping every citizen of that town with a $20,000 debt. Household of 4, that's $80,000 of debt that you never received anything for. How long do you think the town of Bogue is going to continue to have people live there? This is a town killer. They didn't ask to have nitrate in their drinking water. They'll just move. How do you keep that nitrate out? Well, hey, here's a rye cover crop, and this shows you different planting dates of rye, and this is the amount of nitrogen in pounds per acre that rye took up and kept out of groundwater. This is from Maryland, super sandy soil. All this nitrogen used to go right into the groundwater. But you know, there are 70 million pounds of nitrogen in the atmosphere above every acre. Plants can't use it as is, but there are bacteria that can make it usable. Live on these, whoa, that was fast. Someone's wanting to speed me up. I'm talking too slow, or too boring, one or the other. Oh, how do we go back here? There we go. There's the bacteria sitting in those nodules. There's clover. Can make a bunch of nitrogen. Now, what do you see wrong with this? Freshly harvested 90 bushel wheat. What's wrong with this picture? What's not happening? No photosynthesis. There's no green. The only green is in this waste ground in the background. What if that were turned into a nitrogen factory like this? This is also wheat stubble. I'd estimate there's 200 pounds of nitrogen in this biomass. Oh, and guess what? If you ordered before midnight tonight, you don't get Ginsu knives, you get pasture for your cow. Here's hairy vetch. This is being roller crimped down. This is an organic field of corn. It's getting planted. The cover crop's being terminated with this roller crimper. One pass. This is that same field. No herbicide, no tillage, no weeds. 200 bushel, no till, organic corn. I think that's kind of impressive. And no fertilizer. We can still buy it from this guy if you wanna. I'd rather get it from God. Now, if you really want to get serious about putting carbon in the ground, you can use this. Native warm season perennial grasses. Why are they so effective? Well, here's a comparison of the root system of perennial grass to wheat. Wheat in September hasn't been planted yet. No root system at all. In December, you got this. March. In June, you got a root system, but now it's dead. This is ready for harvest. But look at this. You get a maximum of about 3-foot root system versus 10-foot root system 365 days a year. This is where your organic matter is made. Look at that. So when you switch from a crop field to a perennial grassland, this is the kind of carbon you can accumulate. Now, I'll show you my own experience. This is my field. I put in a water line. I dug a trench, and this made me really mad because, you know, the deed on this land told me how far it went horizontally. It didn't tell me how far it went vertically. I didn't know that vertically it only went 18 inches. That was the deepest root I could find. So this is rather alarming. If I expand my farm horizontally, I got to get a bigger mortgage. But I can go vertically and not have to get a mortgage. So I said, I'm going to double my farm. So I started out 1.9 organic matter and 1.5 foot root zone. And I planted that thing to perennial grasses. Here's alfalfa, chicory, super deep-rooted plants. When I took this photo, by the way, everybody assumes, I tell them I'm in Kansas, oh, that's the Garden of Eden, rains all the time. When I took this photo, we'd had 13 inches of rain in the prior 13 months. Rotationally grazed this. 15 years later, 8.7% organic matter. I got a backhoe, the deepest they would legally let me dig without OSHA coming and inspecting it, which I didn't want to do, was 7 foot. And I had an abundance of roots. I stuck this marker in it where the 18-inch. Remember how it looked like gray Play-Doh before? Look at this. This looks like chocolate cake. This is my old subsoil. I turned subsoil into topsoil. What a great, beautiful thing. Now, every time there's a drought, people say, you see this on church signs. I get real philosophical here. I think the existence of this sign is sinful. God is not there to serve us, wherever God is. But God does not exist to serve us. We do not climb on his lap, and he's sitting there in a big red suit and a beard, granting us our wishes. We are here to serve God. And in the very book of Genesis, it says we are put here to be stewards of this land. God is not here to make it rain when it makes us money. If this is your solution to drought, you're messing up. People say, oh, silly Christians, you can't make it rain. Why not? We've been making it not rain for thousands of years. Because land management does have a big impact on rainfall. So there are 3 things, I'll show you how this works. 3 things that make it rain. Number 1 is moisture in the air. You got to cool that moisture below the dew point. If you listen to weather, this is what they talk about. This is what they never talk about. Condensation nuclei. I was taught in grade school that at the center of every raindrop there's a speck of dust. That's not true. If it is, you're messing up. So the moisture in the air either comes from bodies of water, evaporation, or it comes from land. And land can either be evaporation from soil or transpiration from plants. This is what we need to focus on. Because we know from studies done on Pacific Islands, when they cut the forest down, the rainfall drops in half. That's kind of alarming. A lot of these Pacific Islands that were rainforest before settlement, they cut down the trees, build houses, and now they're desert islands. And then once you break that cycle, the small water cycle, now you're into this never-ending drought cycle. How come nobody ever made the same realization that the same thing happens when you plow a prairie. Okay, think about this. Homestead Act, 1860s, 1870s, plowed up prairie. The rule said you had to. 1880s, the first recorded drought in history in this part of the world. Of course, nobody was really recording prior to that. World War I, grain prices go up. 1920s, plow up the plains. 1930s, Dust Bowl. World War II, grain prices go up. War in Europe. 1950s, 54, 55, 56, worse droughts than in the 30s. 1970s, Russian grain deal. We're going to feed the world, plow fence row to fence row. 1980s, severe droughts. 2006 to 2010, ethanol boom. What happened here in 2011, 2012? And it's been happening really ever since. Every big plow out is followed by severe periods of drought. So, evapotranspiration, this is how rain, summer rain in the plains occurs. Land contributes moisture through either evaporation or transpiration. Evaporation is fast, happens for a few days after a rain while the water's on the surface. Transpiration is slow and steady. Goes up in the air, cools, when it gets high enough in there, comes down. The other way that moisture in the air is cooled is when a cold front meets a warm front. And one's moving one way or the other, Arctic air, Gulf air, warm and moist, cold and dry, they hit. So this fight of this front can trigger slow, steady, gentle rainfall. We've lost this. Why have we lost this? Well, this is the air temperature during a field day that I attended. So 97.6 air temperature. This is the soil temperature on bare soil that day. This is later. This is on cover crop soil. 20 degrees cooler, that's 40-degree difference. When you get big areas of hot soil, you create heat domes. Pushes all that moisture away. How many of you have heard that term? It comes from big areas of bare soil. And the water, the moist air masses from the ocean can't get in. Condensation nuclei. How many of you have seen this and know that this means the drought's going to last? That's because there's dust in the air. Dust in the air makes it impossible for it to rain. It's got the wrong kind of condensation nuclei. Condensation nuclei are particles that attract water vapor. Soil particles cannot attract enough water vapor to fall out of the sky. They take massive amounts of moisture in the air, and then when it happens, it's a flood. So these are fungal spores under a microscope. See this thing here? This is the photo, this is the diagram. This thing here is a water droplet. Plant pathologist was studying disease, found he was trying to predict disease, said, well, when we get fungal spores and rainfall at the same time, we're going to have disease. Guess what? 100% correlation in timing. Put these fungal spores under the microscope and, wow, these fungal spores are pulling moisture out of the air. They're making their own rainfall. That's how they've survived millions of years. They create the conditions. They have a sugar that attracts moisture out of the air. So if we want more rainfall, we want more mushrooms. Another condensation nuclei, leaf-inhabiting bacteria like this Pseudomonas. When you have areas without condensation nuclei, remember the New Mexico fires 2-3 years ago? That great big area that burned here, I took this picture of the weather map of the rain event. Every place in the plains got rain except downwind of this burnt area. There were no condensation nuclei. So what if we spend all this money on climate change and it turns out to be a myth? Well, what if we get all this in exchange? If that's the case, it's okay if we're wrong. Doesn't matter. We've still made a better world. I want a world, I think we all want a world where we can raise happier, healthier children. Oh, I'm sure I've used well over my time allotment because he's coming up here to grab my neck. So there's my information. I'm out here at the Rooted Ag booth, got some books and stuff, but get a hold of me. So,
let's give Dale a hand.